This is a video from section 8.2. The directions say to find the exact area of the surface obtained by rotating the curve about the x-axis. So let's go ahead and start with example 1. Example 1 says y equals x to the third. That's my curve. And x is less than or equal to 2 and greater than or equal to 0. Now, the formula we need for this is the following. Now, S is surface area, and that's going to be the integral of 2 pi y ds. That's how I remember surface area. Now, I'm going to show you how to apply this formula. Now, ds is the square root of 1 plus dy dx to the second dx, or ds is the square root of 1 plus dx dy to the second dy. Now, in the context for this question, since y is a function of x, this is the version of ds that we're going to need, okay? Now, s is the integral from 0 to 2, because remember x is between 0 and 2, of 2 pi. Now, y is x cubed, and then I'm going to take the square root of 1 plus, now, dy dx is 3x squared. And then I'm going to square that, and then I'm going to integrate this whole result with respect to x. So I'm going to pull the 2 pi out in front. I'm going to integrate from 0 to 2 of x cubed times the square root of 1 plus 9x to the fourth dx. So we could do this by use substitution. Let u be 1 plus 9x to the fourth. Du is 36x cubed dx. So x cubed dx is 1 over 36 du. Now remember, when x is 0, I'm going to plug 0 in for x and solve for u. I get u equals 1. And then when x is 2, I get u equals 145. Come over to here. So I'm going to get 2 pi over 36 times the integral from 1 to 145 of square root of u du. So 2 pi over 36 is pi over 18 times 2/3 u to the 3 halves from 1 up to 145. So this is pi over 27 times, replace u with 145, you get 145 to the 3 halves minus, now replace u with 1 and you get 1 to the 3 halves. Simplifying just a little bit further, we could also write equals, by the way. We get pi over 27 times 145 square root of 145 minus 1. And that right there is example 1. Example 2. Suppose I had y squared equals x plus 1, where x is less than or equal to 3 and greater than or equal to 0. Now, if y squared equals x plus 1, y is the square root of x plus 1. Okay? I don't have to worry about y being negative, so we're taking the principal square root of x plus 1. dy dx is 1 over 2 times the square root of x plus 1, like so. Now, remember the formula is S for surface area is the integral of 2 pi y ds. Okay? So therefore, S, and remember y is a function of x. So we're going to go we're going to take the integral from 0 up to 3 of 2 pi times. Now, y is square root of x plus 1. So I'm going to replace y with square root of x plus 1. And then I'm going to multiply this result by the square root of 1 plus dy dx, which is 1 over 2 square root of x plus 1 squared dx. So let's go to the next page. So we get 2 pi times the integral from 0 to 3 of square root of x plus 1 times the square root of 1 plus 1 over 4 times x plus 1 dx. So this is 2 pi times the integral from 0 to 3 of square root of x plus 1 times the square root of 4 times x plus 1 divided by 4 times x plus 1 dx. So I just got a common denominator and then combined. Okay? And so this is 2 pi times the integral from 0 to 3 of the square root of x plus 1 times the square root of 4x plus 5 divided by 4 times x plus 1. So I distributed the 4 inside and then took 4 and then added 1 to get the 5 in the numerator inside the radical dx. So this is 2 pi times the integral from 0 to 3 of the square root of x plus 1 times the square root of 4x plus 5 divided by 2 square root of x plus 1 dx. So I took the square root of the numerator and the square root of the denominator. The square root of x plus 1's cancel, and this 2 cancels that 2. So it simplifies very nicely into pi times the integral from 0 to 3 of the square root of 4x plus 5 dx. So I'm going to let u be 4x plus 5. du is 4 dx. So dx is 1 over 4 du. Now, when x is 0, u is 5, and when x is 1, u is 9. So you get pi over 4 times the integral from 1 to 9, right? Well, actually, remember when x is 1, the upper limit is 3. So we're going to change that to x equal 3. U is 9. U is, not 9. It's 17. There we go. And so we're going to change these limits. And let's try that again. So we're going to go from 5 to 17 of the square root of u du. So this is pi over 4 times 2/3 u to the 3 halves from 5 to 17. So this is pi over 6 times 17 to the 3 halves, right? I just replaced u with 17, and then I'm going to subtract 5 to the 3 halves. So I replace u with 5. And so the answer here is pi over 6 times 17 root 17 minus 5 root 5. And that right there is example 2. Example 3. Suppose I had y equals square root of 1 plus e to the x, where x is less than or equal to 1 and greater than or equal to 0. If I take dy dx, I get 1 over 2 square root of 1 plus e to the x times e to the x. So let's see if we can simplify this a tiny bit. So if I take dy dx squared, I get e to the 2x divided by, we'll square the denominator as well. So we get 4 times 1 plus e to the x. So 1 plus dy dx squared is 1 plus e to the 2x divided by 4 times 1 plus e to the x, right? So I'm just going to get a common denominator. So 1 plus e to the 2x divided by 4 times 1 plus e to the x is 4 times 1 plus e to the x over 4 times 1 plus e to the x plus e to the 2x divided by 4 times 1 plus e to the x. So you get 4 plus 4e to the x plus e to the 2x. So if you notice, I just distributed the 4 in, and then I divide by 4 times 1 plus e to the x. So we're doing a little bit of upfront work, right? And so this is e to the x plus 2 to the second, right? That's a perfect square in the numerator. And I'm going to divide by 4 times 1 plus e to the x. Now I'm ready, because now s is the integral of 2 pi y ds. And so this is the integral from 0 to 1 of 2 pi y is square root of 1 plus e to the x. ds is going to be the square root of this mess. So I get the square root of e to the x plus 2 to the second divided by 4 times 1 plus e to the x. So I'm going to integrate this whole thing with respect to x. So you get 2 pi times the integral from 0 to 1 of square root of 1 plus e to the x times the square root of the numerator is e to the x plus 2. The square root of the denominator is 2 square root of 1 plus e to the x dx. The square root of 1 plus e to the x is cancel. The 2's cancel. And so what you have is pi times the integral from 0 to 1 of e to the x plus 2 dx, like so. And so this is pi times. Now I get e to the x plus 2x evaluated from 0 to 1. Plug the 1 in, I get e plus 2. Plug the 0 in, I get 1. And so the answer is pi times e plus 1. That's example 3. Example 4 is interesting. Now, I want you to notice in example 4, we're still rotating the curve about the x-axis, but this time x is a function of y. So we get x equals 1 plus 2y squared, and then y is less than or equal to 2 and greater than or equal to 1 this time. So the formula is still S for surface area is the integral of 2 pi y ds. But this time x is a function of y, so ds is going to be the square root of 1 plus dx dy this time, squared dy. Okay, so we were going to want to ultimately integrate with respect to y. So we're going to integrate from 1 to 2. Notice y is between 1 and 2. Now, this time I don't have to transform y. I just leave it alone, okay? Because we're everything is being written in terms of y. And then I'm going to take the square root of, so I'm going to take y times the square root of 1 plus, now dx dy is 4y. So I'm going to take 4y to the second power dy. And remember, here, I need that 2 pi. So I'm going to put that here. So we'll pull the 2 pi out in front of the integral, and we're going to integrate from 1 to 2 of y times the square root of 1 plus 16y squared dy. So let's write that on the next page. So we have 2 pi times the integral from 1 to 2 of y square root of 1 plus 16y squared dy. So I'm going to let u be 1 plus 16y squared. Du is 32y dy. So y dy is 1 over 32 du. So we're going to take 2 pi over 32, and we're going to multiply by the integral of. Now, when y is 1, u is 17. When y is 2, u is 65. So you notice I'm plugging it in up here. I'm plugging in the values of y and solving for u. And I'm going to take the integral of square root of u du. So this is pi over 16 times 2/3 u to the 3 halves, evaluated from 17 up to 65. Like this. So this is pi over 24 times, now I'm going to plug 65 in for u, and I'm going to get 65 to the 3 halves. Plug 17 in for u, and I get 17 to the 3 halves, and I subtract them. So this is pi over 24 times 65 root 65 minus 17 root 17. And that's how you do example 4. Let's do one more example for this video here. So for example 5, suppose I had x equals 1/3 times y squared plus 2 to the 3 halves. Now notice again x is a function of y. So we want dx dy this time. So I'm going to take 1/3 times 3 halves times y squared plus 2 to the 1 half times 2y. So this is just chain rule. The 3's cancel, the 2's cancel. We get y times y squared plus 2 to the 1 half. So if I take 1 plus dx dy, to the second, we get 1 plus y squared times y squared plus 2. So I just squared each factor. And so this is 1 plus y to the 4th plus 2y squared. And so if you don't mind, I'm going to write this as y squared plus 1 to the second power. Makes it nice. Now, by the way, for this example, y lives between 1 and 2. Okay? Now, the formula is still s is the integral of 2 pi y ds, because we're rotating about the x-axis. And so therefore s is the integral from 1 to 2 of 2 pi. Now remember, we don't have to convert y. We're integrating with respect to y, so we leave it alone. And we're going to multiply by the square root of y squared plus 1 to the second. dy. So pull the 2 pi out front, and we're going to integrate from 1 to 2 of y times y squared plus 1 dy. So this is 2 pi times the integral from 1 to 2 of y cubed plus y dy. So this is 2 pi times, we're going to get 1/4 y to the 4th plus 1/2 y squared, evaluated from 1 to 2. So this is 2 pi times, I'm going to get 16 over 4. I'm not writing 4 yet, and you'll see why in a second. Plus 4 over 2, right? Replace y with 2. And then I'm going to subtract 1 over 4 plus 1 over 2. And so 16 over 4 minus 1 over 4, that's 15 over 4. 4 over 2 minus 1 over 2 is 3 over 2. And so this looks like 2 pi times 21 over 4. And so the answer here, and by the way, I just got a common denominator of 4. So the answer to this question is 21 pi. Let me write that again. So the answer is 21. Let's try that again. 21 pi divided by 2. That'll conclude this video for section 8.2. And we did 5 examples of finding the surface area by rotating the curve about the x-axis. Thank you.